Hi everyone, my name is Charles Lim and I am here to discuss and teach you on how to solve the rational inequalities. Please join me, let's do this. A rational inequality is composed of rational expression combined with a greater than equal, less than equal, greater than, or less than sign. Solving rational inequalities is very similar to solving polynomials because rational expressions have denominator and therefore may have places where they are not defined. You have to be a little more careful in finding your solution. And this is now the technique on the rational inequalities. This is the technique. This is the single fraction. This is the single fraction in the rational function, and this is polynomials and polynomials, and this is the inequalities, and it can be written in another sign, and it's greater than, less than, equal, and greater than equal. So this is now the technique on how to deal with the rational inequalities. In solving a rational inequalities, it has a four-way to solve it. First, write the inequality with a single rational expression on the left hand side of the inequality and 0 on the right hand of the inequality. Second, determine by the settings the numerator equal to 0 and settings the denominator equal to 0. Third, use meaningful number to separate the number line in the interval. And the last way is test for the meaningful number if they make the inequality true or false. If true, then they are part of the solution. If false, they are not part of the solution. So, for now, we were going to solve an example of rational inequalities. This is example. Now, this example is at the first step because it separates the 0 and a single fraction. So we will now proceed to the second way on how to solve the rational inequalities. And the second is to find the zeros of the numerator and denominator. So easy. We will now find the 0 of the numerator and denominator using this. This is it. The numerator has equal to 0 and then the denominator has an equal. So for the x to have a value, we need to move the 7 to the other, and now it will become x equals to -7, and the denominator will become x equal to -3. So we will have now the zeros of denominator is -7 and the zeros of numerator is negative 3. This. So we will now proceed to the step 3 and step 4. So we already have the step 3 and 4. In this step, this is the final step. It will see if the number is true or false. So first step, we draw a line, and it has the negative numbers, and the 7 is here, the 3 is here, and first is this. Let's test if the negative 8 is greater than 0. So the x value in this equation, at the equation, is changing to negative 8. So this it results with 1/5 greater than 0. So it's true, it's greater than 0. So the negative 8 is greater than 0. So let's to the next step. Let test the negative 5. So let's change the equation. The x change to negative 5, and it will result to 2 over negative 2 greater than 0, round off to negative 1. So false. So 0 is greater than negative 1. So it's false. And the last is let's test the 0. So the equation is this. So let's change the value of x to 0, and the result is 7/3 greater than 0. So it's true. So 7/3 is greater than 0. So this is now the final answer. We did this infinity. This 8 is already infinity, and we did 7 because 7 is, it will result in true if we change this into 7, and the 3 there is extraneous if we add 3 there, and infinity go over there, and that's all. That is the final answer.